Okay, you guys. Shh. Elias, Missy, I need you guys focusing here. Put your iPad away. Rusban, put your feet down, Merdice, please. Okay, we're going to do this worksheet. We don't have, I don't even know if we have that. Maybe we do. But we're going to solve a system of equations. Okay, does anybody do snowboarding? Yeah. Okay, do you own your own snowboards or do you rent? I've never, Elias, I've never done snowboarding, but if I were, I would rent because I don't know if I'd like it. I ski. I don't even know if I could do it, to tell you the truth. Probably not. Okay, so the question is, and we're going to be doing some word problems in this unit, is it better to rent your equipment or buy it? Well, that all depends. If you're like me, you're not going to go snowboarding very much. It's probably better to rent. So we are going to write some equations here to represent what the cost is. Okay? I'm not sure what those things are. I think I skipped all that. Now, we're going to write two equations and two unknowns. That's what a system of equations is. You're going to have two equations and two things you don't know. Bernice, put your feet down on the floor, please, and face the front. Thank you. I know you don't quite fit, but that's okay. Okay, the snowboarding problem is what we're going to write equations for. And we can do some other problems. I've got a cell phone problem we could be doing too, which I forgot about that, which is nice. So there's our snowboarding problem. And here are your costs. And you have that. There's not much, there's nothing there. Two equations with two unknowns. Now, did you guys see Apollo 13? That's when they went up in the spacecraft and everything broke down. They had to do all their mathematics by hand because the computers didn't work, and they had lots of systems of equations. The equations with like maybe 40 equations with 40 unknowns. That's a lot trickier to solve. It's easy to do two equations with two things you don't know. But there's a lot of things like that that are like that. We use matrices to do that. Okay, ready? So a lot of applications. Why have we been doing all this line stuff? Well, it's linear algebra. That's one thing. And the other thing is that it has got great applications. Now, lift tickets are $50 a day. That seems pretty high. And your equipment rental is $25 per day. I don't know. I haven't skied in a few years. I don't know where you are. If you were here in Minnesota. Really? It's that much? Wow. And I know if you go out to the mountains out in Colorado, it would be that much. If you buy your equipment, it's $400. If you rent, it's $25. So, but no matter what you do, even if you own or you rent, you're still going to pay that $50. Everybody has to pay the $50. So we're going to go over here and we're going to write some equations. Write an equation for each situation. This will cost you $50 a day for a lift ticket. So this is what it's going to cost you. It's going to be $50, and you're going to rent $25 a day. So for one day, it's going to be $75. Okay, so it's going to be $50 plus 25, and they're going to say let X equal the number of days. And we could use graphing calculators. If I can find enough graphing calculators, we could do some stuff with graphing calculators. Rusman, put your iPad away, please. Bernice, put your iPad away, please. We only have like 20 minutes. So this we're going to model with this. Y equals 75x. Okay? Y represents your cost of snowboarding if you're going to rent. Now, if you buy, you still have to pay $50 a day, and your one-time purchase is of $400. So if we have the equation here, but let's understand it. You got to pay the $400 plus you have $50 for each day. So you multiply that, and they're going to call that Y. I wish they hadn't done that, but that's what they did. Okay, Merdice? And I want to find out when they're the same. That's my goal. Yep. And we're going to do it again this year because this is linear algebra. Ted, you're supposed to be focusing here. Okay, so let's graph Y equals 75x. How do I do that? I like a table of values. Now, you should have a graph on there. I probably printed up the whole thing. Oh, yeah, I see those are there. Oh, we're skipping that for right now. Let's do this problem. So we're further in the packet. Let's do the snowboarding problem. What's your cost? Do you want to do slope? Means I go over 1, up 75. That's not very good. So we'd have to graph this. I don't like that at all. Maybe we should use a graphing calculator. If I go over 2 days, that's 150. So that's going to look like this. If I go 4 days, it's still a slope of 150. So this is going to look like this, etc. And the other one was y equals 400 plus 50x. You know what? I don't like this problem. That's going to start here, but the slope isn't as high. So if I go over 2 days, that's 100. So it's going to look like this, and I want to see where they intersect. You can see what's going to happen. The rental, even though in the beginning is less, and later on, it's going to be more expensive. So if I like snowboarding, it's not smart for me to do this. Okay, I don't like this problem because it's not going to fit on our graph very well. But I realized that they were graphs there. I didn't see that. Hi. Okay, so let's graph this. This is what our goal is here, you guys. We're going to graph this. Now, you have graph paper, and I'm sorry I jumped around a little bit too much, but we're going to go to page 3. So I got to go back. I got to go back another slide. There it is. And I've already given you the graph. Guess I got to fix this. Well, I'm not teaching this next year, so I don't have to worry about it. Okay? Which one's which? Which is y equals 2x? I'm going to write them up here because I can't see them there. And y equals negative 2x plus 4. Call that line A, call that line B. Which one's which? Do you know which one's which? Okay, we're on page 3. Graph y equals 2x. Where does y equals 2x begin? Are you on the right page? Page 3. You know? I switched it up because I didn't realize the graphs were there. So we're on page 3. Nick? Is it this one? Okay, this is graph A, and then this is graph B. And you just did all this graphing. This one starts at 4 and a slope of negative 2. Can you read this point off the graph? That's really what I want to get out of this. What's the x coordinate? X is, well, we're going to assume these are 1 each, okay? So that's 1, and the y coordinate is 2. So that's what we're going to be looking for. Where do they intersect? Now, lines don't have to intersect. They could be parallel, too. Let me see what this pole here is. I didn't write this smart for it, so. Okay, that doesn't work. There.
You guys don't need your iPads right now.
No, there should be no iPads out. Gabe? There you go. Okay. Oh, what happened to that? Oh, there it is. Now, remember what a solution is? What's a solution? It's a number that makes a sentence true. If I put this point, this ordered pair, into both of these equations, both will be true. Let's try this one. Y equals 2x. What's the y value here? 2 equals 2 times 1. Is that true? Yeah. This is one way to solve these. You can graph them. Okay, what if I put them into the other equation? It's 1 comma 2. What's the y value? Okay. What's the y coordinate? No. X, y. 2. Is that equal to negative 2 times 1 plus 4? What's this going to give you? Negative 2 plus 4 is 2. That's true, too. So on the next page, let's turn the page. Those are the graphs. We're not asking to graph. Can you tell me where the solution is? Where is the ordered pair that makes both true? It lies on both lines. What is this point right here? Do you guys know? No? What's the x? X is, you're going to the right, 3, and then you're going down 2 to get there. So it's positive 3, negative 2. Do my little trick again. And then we'll just do some problems. There it is, 3, negative 2. So that's what our goal is. You are going to graph the lines You know how to do that. And then write down the ordered pair where they intersect. Right point of intersection. We like to do this a lot. It's a lot of applications for intersection points. There is one other thing I want to say is what can happen to lines. I don't like any of this stuff. I knew I didn't like this slide. Oh, there we have it graphed. Let's see where that intersection was. On our snowboarding problem. This is Whittle of it, and it's a nice one, but I don't care for it. Okay, let's see. How many days is that? That's 16 days, and what's the cost going to be? $1,200. Whoa, who's got that kind of money? Guess if you want to snowboard, you got that kind of money. So after 16 days of rental, you're better off to have bought. Well, then you think about it. Are you going to go snowboarding more than 16 times in a year? Me? No. But you guys, how often do you snowboard? Wow. Every other day? You guys should get out there today, right? More than 16 times? 16 times is actually a lot of times. Because winter is not, I mean, winter is long, but do you go snowboarding 2 days a week? I don't know. I would only go skiing one day a week. Well, then count how many weeks. There's only weekends there are. There's only 4 weekends in a month. That's 4 months of weekends. Winter sometimes isn't that long. Not this year. This year it's terrible. Okay. That's terrible. Let's see what this little slide is. Oh, then they get this represents when the renting is less expensive. So, I mean, that's every weekend, every month of the winter. But if you count it over more years, if you say, oh, I'm going to go renting for a couple of years, then no, that's not good. Then this one represents buying, when buying is cheaper. Okay, so what can lines do? You could have lines do this, right? They intersect in how many points? 1 point. You could have lines do this. Railroad tracks are examples of these. What do you say was true about those lines? If they don't intersect, they're called parallel. What points lie on both lines? Gabe, what points lie on both of these? Are there any? No. So we say there's no solution. You can write it like this, or you can write it like that, with a 0 with a line through it. Okay, Ted? So you know what you're doing? Well, you're going to see some of these when you do the worksheet. Or the last thing is you could have a line like x plus y equals 5. And then you can have a line like 2x plus 2y equals 10. And guess what? Those are the same lines. Actually, the slope's negative. So I should have them oriented differently, but that's okay. Okay, so that's called coincident lines. That's not going to happen too often. And what numbers make these true? All of them. X plus y equals 5. All of them lie on the line. I'm not going to use set builder notation because it's not worth it. So our job today, and I have some rulers here too, is to graph lines and find where they intersect. So we'll get started. Let's do maybe the first 2 together. Really? Where are my pencils? They're there. Oh, we have a little time. Oh, we have 10 minutes. Here you go. We'll do the first 2, then we'll come back on Monday and do this and practice a little more graphing. But you should know how to do this because it's simply graphing and reading the point off where they intersect. And there's only 8 problems, so it's not like it's a lot.
Thank you.
You're welcome. Okay? Do you have it? Otherwise, there's another one. Yep. Oh, yeah, where is he? Here you go. Now you get to draw on your thing. You've already done this, unless you want another one. Okay. I won't take it if you don't have a name on it.
Oh my God.
Brisbane, sit down. Now, there's other ways to solve systems of equations. There are other ways to do this. This is one way to do it. Now, graphing has its issues, as you saw with the snowboarding problem. Ted, sit down. Sit down. As you saw in the snowboarding problem, it was hard to get the window set up and to graph that. It wasn't very easy. But let's do this one. I'm going to get a graph here. Maybe. Today is the 19th. And let's go ahead and do this. Y equals 5x minus 2. And let's do different colors. Y equals minus x plus 4. So let's graph those. Different than the notes. The graphs were already given to us. Okay, Jake? Where do I begin with the blue one? Where do I begin with this one? Isn't it? Negative 2. You guys know this, don't you? And I'm going to go up 5 according to Paris. 1, 2, 3, 4, 5, and then do it to the right 1. And I want a nice line. So to get a nice line, I'm going to need a ruler. I don't know if I have enough. So draw a line. You could use your phone as a straight edge. Put your iPad away, please.
Doing work.
Yeah, no, I'm teaching him.
Hello, I'm from Mexico.
Well, Gabe, why don't you do some math here? If you take 6 minutes times 5 days a week times 40 weeks in the year.
Yeah, Gabe, do some math.
Yep, come on, graph that. 5 minutes a day is a lot of time. You'll have to use a straight edge of some sort. I only have so many. Okay, so we're going to draw the line. I should see the line drawn on everybody's paper. Yes, Elias is ahead. Yeah, this is the worksheet. So this is the first problem on the worksheet, number 1. Yes, it should be easy. Okay, where do we begin on the red one? No shading. Guess what? This is not inequalities. It's easier. Okay, Jake, where do we begin with the next one?
You begin at 3.
No, I don't see a 3 there. 4. Okay, now what's the slope? Alex, you know what we're going to do next? I can't hear you because of Merdice. What? I'm going to go over 1 and then what? Down 1. Over 1, down 1. Did I get my other one wrong? 5x, 1, 2, 3, 4, 5. Oh, my point. I went over too far. Did you guys see what I did wrong?
Yeah.
Oh, dear. Well, we can fix that. Come on, I should rotate. There we go. Can't count, can I? Okay. This was over 1, down 1, and it's going to look like this. Where do they intersect, Ted? Jake, where are they going to intersect? What's the x value?
3.
No. X value is 1. What's the y value? 3. Okay. Bernice, number 1 should be done. Don't forget to read the ordered pair off the graph. That's all that's different. We're going to graph 2 lines and maybe see if they intersect. Let's skip down to number 3. Okay? Let's skip down to number 3. Where's your graph? Let me see. Read, you haven't finished it. If you don't have the ordered pair here, you have not done the problem. Okay? 1, 3. Everybody should have that. Let's do number 3. 1 is done. I'm going to move on to number 3. Just graph them. There's not. All we did was add one little piece of newness. That's it. Okay, so shall I do it on the same slide? I will. Okay, let's do this one, and so I can still kind of keep it there for those who are behind. And it says y equals negative 4x plus 2. Let's graph that one. Jake, where do I begin? 2. Josh, I'm going to begin at 2. What's my slope? How am I going to get the next point?
Your slope is. Time out. That's negative.
I see a positive 2 here. Oh, we're doing number 3. So we're going to count what? Negative 4 slope. What am I going to do? Whoops, didn't do that. What does negative 4 slope mean? Go down 4. 1, 2, 3, 4 to the right 1. And I'm going to draw my line. Looks like this. Well, that's kind of weird. Why is it doing that? And I'll try to fix that a little bit. Okay, let's do the next one. And that'll be our last one. And that's going to be y equals negative 4x plus 4. I haven't finished though. Okay, Merdice, where do I begin on this one? This is the red. This is 4. And what's my slope? 1, 2, 3, 4 over 1.
Is this number 3?
Yes, it is. It says 3. We won't have time.
You guys confused me.
What's going to be true about my lines? They're parallel. I knew that before I started. Why? Not similar numbers. What's true about your slopes? They're the same. Ted, what's true about the slopes? They are the same. Same slopes. Okay, how many numbers make both equations true at the same time? Are there any, Rusman? There aren't any numbers that lie on both of those graphs, Marie, at the same time. Ted? We don't have a very long class. I want to get this finished. We'd be done by now if you pay attention. What numbers make both true? What numbers lay on both lines? 4? Is this point on the other line? Marie? Is this point on that line? No, it isn't. Does this line go through that point? No. Do you know? Jake, how many points make this both true? Yeah. No, there aren't any points. Empty set. Okay? Enjoy the snow. Go listen to your voting stuff.